This is one of like the key things for Algebra 2. If you can factor things, you are off to a great start. Hi, I'm Sarah. I've been a STEM teacher for 20 years, and I like to make math engaging and fun and not so scary for everyone, all ages. I do private tutoring and mini lessons and things like that. If you need more information or you want to reach out about tutoring and setting it up in person or Zoom, click the link and do the stuff. So again, if I said to factor 24, we've got 1 and 24. Don't forget that one. We've got 2 and 12, right? And the way that I'm doing these is because 1 times 24 is 24. 2 times 12 is 24. 3 times 8. 4 times 6. Now, after that, I'm just back at 6. So I don't need to factor it anymore because I've kind of made like a loop. Excuse me. But 24 is one of those highly factorable numbers, right? There's lots of things, just like 60 and 36 and 30. Those are really highly divisible numbers. They have lots and lots of factors. So if I said to factor 24, I would say, okay, well, it's 2 times 12 or 3 times 8 or 4 times 6, right? We can still do this with polynomials. Polynomials is where you've got many names. Poly is many, nomials is terms. So polynomials, I'm going to work a little bit backwards for this one. If I have two binomials, x plus 3 times x plus 4. So to multiply these together, okay, we were talking about the distributive property earlier. We need to make sure that everybody gets multiplied by everybody, right? This is a little bit different situation than we were talking about at the very beginning because that was just like one term being multiplied through this. I've got 2 terms here and I've got 2 terms here. So I need to make sure that everybody gets multiplied together. So there's an easy acronym that people use, that lots and lots of people use when you're multiplying binomials together. Some of you, this may like unlock some deep thing in your mind palace. It is FOIL, okay? So foiling is just an easy way to remember that you want to multiply everybody together. Okay, so we say it's FOIL, F-O-I-L. That means you multiply the first 2 terms together, then you multiply the outside terms together, then you multiply the inside terms together, then you multiply the last terms together. The first 2 terms, it's x times x. Oh, that's really hard to see. Okay, I just got a brand new pack of markers. What am I doing only using these few colors? Oh, so f is first. So we've got x times x, okay? And that's going to give me x squared. Now, I am writing this out way longer than I would probably do it for, like once you get through this the first time, it's going to be much faster. The outside terms would be this x and this 4. So we have 4 times x, which is 4x. Inside terms are 3 and x. So 3 times x, which is 3x. And the last terms is 3 times 4. Okay, so 3 times 4, which is 12. Now, these are both positive, so I know everything is being added together. So I can just add everything together. So this is going to give me x squared plus 4x plus 3x, which is 7x plus 12. So when I'm looking at this, going from here to here, that is multiplying. That is multiplying. That is simplifying, right? However you want to think about that. Going from here to here, going from the x squared plus 7x plus 12 to x plus 3 times x squared, that is factoring. This direction is factoring, okay? So you're simplifying or you're multiplying or you're factoring, okay? So we're rewriting it just like we factored this, right? If I'm factoring the 24, I've got 1 times 24, all of that. Factoring this means I'm going to rewrite it as 2 things multiplied together or multiple things multiplied together, right? Okay, so patterns. Usually in my class, I spend a lot of time like kind of pointing out the patterns, like what do you notice about like 7 and 12 and how they're related to 3 and 4, right? Because we can use, if we notice the pattern, we can use that pattern to kind of figure out how to do this, right? So when you look at 3 and 4, right? Because the numbers are where it all lies, right? The numbers are what reveal the pattern. So we've got 3 and 4 up here, we've got 7 and 12 down here. So when we think about those numbers, we've got, oh, 3 times 4 is 12, and 3 plus 4 is 7. And that's the key. That's the key to factoring these trinomials when there's nothing in front of this x squared. So if we think about that pattern, then we can start getting into all sorts of different problems. So we can look into, that pack didn't come with a purple marker? What? Oh no, Staples. Love purple dry erase markers. Okay, so again, if we've got 3 and 4 here, 3 times 4 is 12, 3 plus 4 is 7. So just based on the pattern, if I gave you something like x squared plus 5x plus 6. Okay, so if we think about this, right, and we knew, okay, 3 plus 4 gives me 7, 3 times 4 gives me 12. Then what we're looking for is we're looking for two numbers that multiply to 6 and add to 5. Okay, so two numbers that multiply to 6 and add to 5. So we can think about all the different factors, right, of 6. So 6 and 1 or 2 and 3. Well, 6 plus 1 is 7, but 2 plus 3 is 5. So that gives us our two binomials. So I know that two numbers that multiply to 6 and add to 5 are 2 and 3. 2 times 3 is 6, 2 plus 3 is 5. Perfect. If I factor this, I have x plus 2 times x plus 3. And I can check this by multiplying them together, right? X squared. 3x plus 2x is 5x. 2 times 3 is 6. So this is the factored form. Again, if I multiplied that together, I would get this way, okay? Now it can get a little bit tricky when you start throwing in some negatives, but the pattern doesn't change, right? So if we throw in some negatives on this, so if I have, let's do a squared minus 4a minus 12. Now, I have changed the variable. It's not an x. Oh my goodness. It's fine. It's still a variable. I have changed these signs to negatives. Oh my goodness. Still the same thing. Okay, so we've got a squared minus 4a minus 12. Still looking for the same thing. I'm looking for two numbers that multiply to negative 12 and add to negative 4. So I think about my factors. So the factors of 12, and now since this is negative and they're multiplying together, I know one of them will be negative and one of them will be positive because I've got to have different signs for them to multiply together to make a negative. So 12, I've got 1 and 12. I've got 2 and 6. I've got 3 and 4. And then I'm back to 4, so I'm making a loop. All right. So negative 12, I would just need to make one of these negative. Looking over here, I've got negative 4. So that means I've got to look at, okay, 1 minus 12. I can't make 4 out of that. Now 2 and 6. 6 minus 2 is 4, right? But it's positive. But what I could do is, what if I made the 6 the negative and the 2 the positive? Now I'm onto something. Positive 2 times negative 6. That gives me negative 12. Positive 2 minus 6 gives me the negative 4. There's my binomial. There's my binomial. So I've got a plus 2 times a minus 6. A plus 2 times a minus 6. Again, the commutative property, the order doesn't matter. So I could flip these, right? I could have the a minus 6 times a plus 2. That doesn't make a difference, but I can't do a minus 2 times a plus 6 because that will not give me that minus 4. 2 minus 6 is minus 4, but 6 minus 2 is not negative 4, is not minus 4. Okay, so I've got to keep track of those negatives. MathedUp.